In this example, I want to give us our first case of repeating factors. We're going to do repeating linear factors in this one. All right, so step 1, you'll notice the degree of the numerator is 2, and the degree of the denominator is not as immediately obvious, but it's 3, because this would be x squared, and x squared times x is x cubed. So this is 3. You don't need to distribute it out to kind of be able to see that. All right, so yay. And step 2 was actually already done because the denominator is already factored. So double yay. So step 1 and 2 are done. Great. So this must be an easy problem, right? Well, I don't think any partial fraction problems are particularly easy, but we'll see how it goes. All right, so 16x squared over x minus 6, x plus 2 squared. And again, I'm not going to bother with the integral. I forgot that in the last problem, but we don't need it right now. We'll bring the integral back when we get to step 6. So for right now, we're just trying to figure out how to deal with that integrand in there. All right, so 16x squared equals. Now, remember how this goes. So for repeating linear factors of x minus 6 and x plus 2. So x plus 2 is the one that repeats because it goes to a power. So you'll just take a over one of those factors plus another a or b over that factor squared, right? Okay, so I have an a over, I'm going to get the x minus 6 over with because there's no repeat on x minus 6, plus b over x plus 2. And again, if you want to number these a1 and a2, that's fine. I think for a simple problem like this, it's kind of not worth the trouble, but feel free. And then c over x plus 2 squared. So you have to have one for x plus 2 to the first power and then another one for x plus 2 to the second power. And if it was to the third, you do another one for the third. So you keep going until you get up to the power that you have in the denominator here. Since we have a squared, we're done right there. Okay, so that's step 3. Step 4, I need to multiply everything by the common denominator, which is the denominator over here. So x minus 6 times x plus 2 squared. That will lead me to, over here, 16x squared. Good, that's what we want, no fraction. A times, well, the x minus 6's will cancel, and you'll be left with x plus 2 squared, plus b times, well, the x minus 6 won't cancel, and neither will one of the x plus 2's. So it'll cancel one of them, but not both of them. Or divide away to 1. Plus c times, both the x plus 2's cancel, and you're left with x minus 6. So there's our base equation right there. Okay, so now it's up to us. We can either choose to choose some numbers, something we feel like might work out nicely for us, or we can use the other method. Again, I'm kind of too lazy to bother foiling all this out, so I'm just going to choose some numbers. All right, so a first number I'm going to pick would be x equals 6. I mean, it just makes sense because x equals 6 would make this term go away and this term go away. So I'd be left with 16 times 6 squared equals a, which is what I'm shooting for here, times 6 plus 2 squared. So this is 576 equals a times 8 squared. 8 squared is 64. Right. So then a would be 576 divided by 64, which is 9. Feel free to check it in Desmos, but I'm correct. So there you go. So my equal sign got weird there. All right, next. So that was that one. Let's try, well, negative 2. I mean, that's what's worked for us before, choosing one that makes one of them go away and then the other one. Negative 2 will make a and b both go away. So then that'll be 16 times negative 2 squared equals c, because c will be the only one left, times negative 8. Well, this is easy, right? This is 64 equals negative 8c. So then c is equal to negative 8. Wonderful. Now, for the most difficult one. The problem with b is that if you put 6 or negative 2 in it, both of them make b turn into nothing. So now you just choose a different value, but keep in mind you already know a and c. So it would be a very smart number to choose. How about 0? 0 is good because 0 makes this side turn into 0, which is nice. I mean, generally you pick 0, you pick 1, you pick -1, those kind of things. All right, so 0. But keep in mind, A is 9 and C is 6. So A is 9, C is -8. Oh, sorry, I said 6, but I meant -8. All right, so let's do this. 0, because that side will be 0, equals 9, because I know A is 9. I don't need to mess around with it. 9 times 0 plus 2 squared. That'd be 2 squared plus B, there's the part I'm actually looking for, times 0 minus 6 is -6. See why we chose 0? 0 is such a smart number to pick. 0 plus 2 is 2, so that's easy. Plus, over here, I know C is -8. I can actually just put it, right? C is -8. And then 0 minus 6 would be -6. All right, so now this is a simple equation. We can solve it for B. So this would be 9 times 4 is 36. So 0 equals 36 plus, or minus, I should say, minus 12B. Plus 48. So then bring these two numbers together and over to the other side. They make -84 equals -12B. So B is equal to 7. Actually, I'm just going to put that right here. I just want to leave myself some room to actually do the integration on this problem. All right, so B is equal to 7. All right, then. So this is all step 5. We finally have our coefficients. Step 6, we actually need to do our integration. So, right, actually, I want to give myself as much space as possible. This is going to be a little bit of work here. All right, so the integral of 16x squared over x minus 6 times x plus 2 squared dx is equal to the integral of, and it was 9, that was A, over x minus 6. And I'm actually going to break this one up a little bit just for our own purposes here. So because I'm going to have to do a little bit of work here. So 9 over x minus 6 dx plus, and then it was 7 over x plus 2. Those two are really easy. I don't actually have to separate those two. They're fine. And then minus, or I'll write it this way, plus -8 over x plus 2 squared dx. Right there. All right, so the first one's super easy. Second one's super easy. The third one needs just a touch of work here. So if I do this one, it's 9 natural log absolute value x minus 6, right? It's just plain x there, so I don't need to worry about multiplying by a fraction or anything. Plus 7 natural log absolute value of x plus 2. So those two didn't really need to be separated out. They're pretty simple and straightforward. I could have done those in one integral, no problem. The problem is the third one, because that's a u. Because this is a little bit trickier. So u is x plus 2, then du is dx. So that's easy. It's not a difficult u substitution, but we have to do it. So then this will be -8 integral u to the -2 du, like that, right? Because we have u squared in the denominator, so that's u to the -2. And the integral of u to the -2 is u to the -1. So that's one we haven't really seen before. So this will be u to the -1, and then you multiply by a negative, and then there's already a -8 there. So it's -8 times -1, or 1 over -1, right? Plus c, because because I'll finally throw on the c. So it'd be 9 natural log absolute value of x minus 6 plus 7 natural log absolute value of x plus 2 minus this part with the u. And then I have to go back and back substitute what u was. And while I'm at it, I'm going to multiply 8 times 1, which negative 8 times negative 1, which makes positive 8. So this is 9 natural log absolute value of x minus 6 plus 7 natural log absolute value of x plus 2 plus 8 over u, right? And u was x plus 2. And then I throw in my constant of integration when I finished my last integral, which is that piece right there. Oh, and I should have put equal signs every step of the way. So that's correct. Now, if you want to combine together because of log properties, you can make it the natural log of the absolute value of x minus 6 to the 9 times x plus 2 to the 7 plus 8 over x plus 2. Again, not strictly required, but for fun, there you have it. It's important to notice that we needed to do this piece over here because it wasn't just a bare linear term, right? When it was something squared, we actually had to do a little bit more with it. In this case, a baby u substitution. You could probably get out of this just by writing this down and kind of notating what the integral is and getting to that point, right? But it wasn't as simple and straightforward as the natural logarithms were.